Second problem. On Sem theorem. Find the limit of sequence. For this, Sm is 1 upon n square plus 1, 1 upon n square plus 2. In this way, 1 upon n square plus n. Solution. So this given sequence, Sm is 1 upon n square plus 1, n square plus 2, n square plus 3. In this way, 1 upon n square plus n. This is Sm. So, problem of Sem theorem, suppose I want Sm lie between first left side sequence, right side sequence, lie between less than. So, we will see here in general, we have n square plus 1 or n square plus n is greater than n square plus 1, yes, for all the natural number. N square plus n larger, bigger than n square plus 1. Reciprocal. So 1 upon n square plus 1 will be less than 1 upon n square plus 1. So in case of this less term, I take first of all less term. Okay, it's less n square plus 1. In this way, n square plus n will be greater than n square plus 2 also. Second term. Reciprocal, 1 upon n square plus 1 will be less than 1 upon n square plus 2. Okay, in case of this less term. Okay, in case of this less term. Left side less term, right side bigger term. Okay, in this way. etc. This line. Okay, now right side bigger terms are, these two terms are, we compare. So remember, I want less term. This last term, left side, I say. First term, right side. So now this first two, n square plus 2 will be greater than n square plus 1. Yes, a natural number. Reciprocal, 1 upon n square plus 2 will be less than 1 upon n square plus 1. Or side change, I want a bigger values in case of this n square plus 2. Okay, yes, in case of this bigger value n square plus 1. In case of this n square plus 3 also, n square plus 3 will be greater than n square plus 1 in terms of 1 first term. Reciprocal, n cube, n square plus 3 will be less than n square plus 1. Okay, so its bigger value n square plus 1, its bigger value 1 upon n square plus 1, etc. So right side bigger values, left side smaller values. Therefore, what you see? Okay, so this sequence 1 upon n square plus 1, 1 upon n square plus 2. In this way, 1 upon n square plus n will be less than. Okay, less than, lie between. So I want a less term. So 1 upon n square plus less than 1 upon n square plus n. N square plus 2 will be less than 1 upon n square plus n. In this way, general term 1 upon n square plus n. Less than, left side. Now greater than. Okay, first term fixed 1 upon n square plus 1, and it is first term. After second term, so n square plus 2, 1 upon n square plus 2 less than 1 upon n square plus 1. N square plus 3 will be less than 1 upon n square plus 1. In this way, last term also 1 upon n square plus 1. Okay, so left side less term, right side bigger term. So this now your Sm original is lie between this. So the same term repeated n times. The term right side repeat term is n times. Okay, so this Sm lie between Tn and Un. Let's suppose Tn is n upon n square plus n, and Un is n upon n square plus 1. Limit of this Tn, limit of this. So limit of this, how to check? Algebraic function, n is common, n plus 1, n is cancelled, apply limit n tends to infinity, 1 upon infinity 0. Also here limit of un, same also here, n is common or n square is common, 1 plus 1 by n, 1 n cancel, but 1 is remaining, 1 upon infinity 0. Okay, so limit of Tn 0, limit of un, so Sn will be lie between Tn and un. So limit of Tn 0, limit of un 0, therefore by Sandwich theorem, limit of Sn is also 0. Okay, what is this? This line. Okay, so this Sandwich theorem, second problem. Now second theorems are theorem called as a Cauchy first theorem. Cauchy first theorem on the limits. Cauchy second theorem is like, what is this way? Proof or theorem is, if limit of Sn is real, limit of Sn is real, then limit of S1 plus S2 plus S3 plus Sn sum upon n is also real. Okay, limit of Sn is real, the limit of S1, S2, S3, Sn plus upon n is also real. We will not take proof, very big proofs are. Okay, so now we will take other proofs are. Problem, this example of this. So that limit of this term, root of n square plus 1, root of n square plus 2, in this way root of n square plus n is 1. Taking on this sum S1, S2, S3, Sn upon n, I want n extra. Then apply this theorem. So let us define a sequence, Sn sequence, such that its S1 first term will be n upon under root of n square plus 1, n upon, because I want upon n, that will be cancelled for this. S2 will be n upon n square plus 2 and Sn will be n upon n square plus n. Okay, then by Sandwich theorem, Cauchy first theorem, Cauchy theorem number 1. So limit of S1 plus S2 plus Sn upon n will be here anyone. What is here? 1 only. Check. Listen. Check. So before that, okay, I want limit of Sn only. Check. So limit of Sn will be n upon n upon. So I want here highest power common, root of n square is common, means n will be outside the root, 1 upon n bracket, and n cancel, n tends to infinity, 1 upon 1, so 1 will be answer. Then the Cauchy theorem, limit of this will be also 1. So here limit n tends to infinity 1 upon n. I take outside. Here the n is S1 n upon root of n square plus 1, S2 root of n square plus 2, n upon root of n square plus n is also 1. Take n common from the each terms. N is common from the each term. So 1 upon root of n square plus 1, 1 upon root of n square plus 2, in this way 1 upon root of n square plus n is also 1. So n will be common. Okay. So therefore limit n tends to infinity. Okay, limit of this will be 1. So this answer show that limit of this term will be 1. So show by just previous theorem, Cauchy first theorem. Second theorem, name is Cauchy second theorem. First theorem, second theorem, and one formula. Second theorem होगा, let sequence Sm be a sequence such that limit of Sm is here. Same like first theorem. First theorem for addition. Limit of Sm is here and Sm positive is extra. All the terms are positive of the sequence must be. Then by this theorem, limit of S1 into S2 into S3 into Sn into S2 power 1 by n is also here. Multiple and S2 power also 1 by n. Okay, so today we have proved one. We will prove this theorem. Depend on the first theorem. First theorem. What's the second theorem? Proof depend on the first theorem. First theorem very large proof. That's one. Alright. So let Sn be a sequence such that limit of Sn is here and Sn term, all Sn term are positive. No chance of 0 also, or all the natural number. Now we define a new sequence. Okay? Let us define new sequence Tn. So that this Tn will be log of Sn. Okay, this will be log. Because I want raised to power. I want to raised to power. The rules are there, multiple also. So Tn is log of Sn. Now limit of Tn. Okay, limit of Tn, taking limit. So log of Sn. So limit of log, you know log will be outside. Properties of limits. Property of limits, log will be outside. Limit apply everywhere. The limit of Sn here, log of here. The limit of Tn will be log of here. The limit of Tn log of here. Then by Cauchy first formula. Cauchy first theorem. So limit of Tn is here log of here. Then by Cauchy first formula. But you know, limit of T1 plus T2 plus Tn upon n is also here means here log of n. Simplify n into 1 by n. I take outside T1 Tn log of Sn. So T1 log of S1, T2 log of S2. In this way log of Fn. Okay. Logarithm log A log B, log of A into B. So log of S1 into S2 into Sn. Now logarithm rules again, limit n tends to infinity. So log of S1 into S2 into Sn into 1 by n. Log will be outside, limit will be inside. Okay. Properties of limit S1 into S2 into S3 into Sn into S2 power 1 by n is also log of n. Log हो गए, you can remove also 1 mapping. Log is 1 mapping. So log can be removed or taking anti-log. Okay, thanks bro. So limit of Sn is here, then limit of S1 into S2 into S3 into Sn into S2 power 1 by n is also n. So this is S2 power 1 by n problem. All the problems of related with S2 power 1 by n power. Okay. So problem can be applied. Now see problem. No problem. First one Cauchy theorem and then the problems are. Cauchy formula also. Third theorem is it called as Cauchy formula. Now this problem okay, just to probably answer problem here multiple. Now here okay, ratio. Let Sn be a sequence such that Sn is positive, all terms are positive for all natural numbers. Again, this system of positives are. Then limit of Sn single term. There are multiple terms. Right? So limit of Sn raised to power n by n, no problem. Raised to power 1 by n here will be what? Limit of this means limit of Sn upon Sn minus 1. Limit of Sn upon Sn minus 1. Or it will be applied for limit of okay, n then Sn plus 1. n minus 1 then n. 1 times n. N then n plus 1. So this is a better okay, in the problems. Okay, this is better in the problem in case of this. Okay, so again proof of this. So let Sn be a sequence such that Sn is positive for all the natural numbers. Then is like a ratio. Again, I want a new sequence. Let us define a new sequence Tn such that T1 is plus 1 by 1. After T2 this like T2 or Tn will be this like ratio Sn minus 1 and Sn, that is after 1 because T1 is S1 n equal to 1, this after 2 T2 T3. Now limit of your Tn. So limit of right side Sn upon Sn minus 1. Okay. If suppose RHS limit is exist, say here limit of this right side limit is exist, say L or any one symbol. So limit of Tn n tends to infinity equals to limit of this, and limit of this right side will be existable. Suppose say L, say it is a L. So limit of Tn will be L. Okay. So then by Cauchy first formula, by Cauchy first theorem, what you know, limit of Sn is here. Then limit of T1 plus T2 plus Tn upon En is also L. L means this. I take this notation, say, assume. But actually I want this for you. Just notation. So limit of Tn will be L and limit of. So what is now T? N. Okay. So N outside I take T1. T1 is S1. No, not Cauchy first formula, Cauchy second formula. This for plus, I want it for multiples. Okay? So by Cauchy second theorem. So limit of and then S1 into S2 into Sn into S2 power 1 by n is also here. What is second formula? I want a multiple term. Multiple second theorem. So limit n tends to infinity. So S1 T1. Sorry. For T1 into T2 into Tn. So T1 is S1, T2 is S2 upon S1, T3 is S3 upon S2. In this way, Sn is Sn minus 1. Erase that. Sn minus 2, then Sn minus 1. S2 power 1 by n is also L. S2 cancel. S1 cancel, S3 all cancel except last Sm. So limit n tends to infinity of Sm S2 power 1 by n. So here L is limit of Sm upon Sm minus 1. Okay, so this we apply for problems tomorrow.